Hello students, in this video we'll discuss our third lab program. To draw a colored cube and spin it using OpenGL transformation matrices. First step is I have to draw a colored cube, then I have to spin it. First we'll discuss how to draw a colored cube. So if I take a cube, this cube it will have 8 edges and 6 faces. 8 edges and 6 faces. So how to mark these edges? It's my question. So here I have marked these 8 edges of my cube in this order. That is, I have marked in clockwise order 0, 1, 2, 3, here 4, 5, 6 and 7. 8 edges I have marked. Now how to take these values? How I got these values we can discuss. So this is my origin. So this origin you can take as -1, -1, -1. And you assume this cube is 2 units cube. That is, each side it is of 2 units. Right there. So cube it is of 2 units. That is, each edge it is of 2 units. So if this is origin is -1, -1, -1. How to get the other edges? Keeping this origin as the reference, I have to get the other edges of my cube. So it is 2 units. So when I reach half of the distance, see this, I am traveling along x-axis. So when I reach half of the distance, I will be reaching 0. So another half. So when I reach at this edge, definitely I am traveling along x-axis, so definitely x it will be +1. I am not disturbing y and z. So one more thing you have to keep in mind, this third program it is a 3D object. I am going to draw a 3D cube. So I told cube it will have 8 vertex. All this 8 vertex it will have 3 coordinates. Each vertex of your cube it will have 3 coordinates x, y and z. Since it is a 3D cube. So here it will be +1, y and z remains the same, that is -1, -1. Next it is, I will be marking this edge, I will be marking this vertex. So here I assume you are here, now I am traveling along y axis and I have to mark this vertex. So since I am traveling along y-axis, when I reach half of the distance, I will be reaching 0. So another half, my y becomes +1. So here x and z remains as that of the previous vertex. So here x is 1, z is -1, x1, z -1. Here y is -1, here it is +1. So -1, 1. Clear? Similarly, you have to mark this edge, this vertex. So I am traveling along which axis it is? This is x-axis. So x remains changing. So here it is 1, here -1. The other two remains the same. 1, -1. Here also it is 1, -1. Right there. One completes it over. Next, coming to this, try to mark this vertex. So this vertex is your z-axis. So from here, when I travel along z-axis, there will be only change in z-axis, and x and y remains the same. So here -1, -1, -1, -1. Here it is -1, it becomes +1. Similarly for other vertex also. So I'll get the values for all my 8 vertex of my cube. Now you can check these values with this one. It will be same, right? So the order will be, first you have to write the coordinates for this 0th vertex. What is the coordinate for 0th vertex? It is -1, -1, 1. Right, -1, -1, 1. So I have written in the same order as that of this marking. 0, 1, 2, 3, 4, 5, 6, 7. So you follow the same ordering. Now you have to find out the normal for these vertices. And for every vertex, you have to assign the color. Every vertex, you have to assign the color. Totally, you have 8 vertices. So you can give a color of different RGB combinations. It can be of any combination values. So based upon that, you will get your vertex color. It is not needed to follow the same values. Any RGB value you can give it. Next is, we can start with our main glut init display mode. So what are we doing in our third lab program? We are drawing a color cube and we have to spin it. You have to create a color cube and you have to spin it. And this program, it is of 3D program, 3D cube. So I need 2 buffers. So in glut, while initializing your display mode, you have to specify double buffer. It is mandatory. And color system is RGB color system. Since we are using this double buffer, I'll be using this depth buffer also, because I have to spin my cube. So I need both the buffers. In one buffer will be displaying the object, and at the same time the back buffer will be rendering the object in the next position. So I need 2 buffers and I need a depth buffer also. And you can initialize your window size. You can name the title for your created window. And here you are having few callback functions: glut reshape function, glut display function, glut idle function, glut mouse function. These are your callback function. Since we have used this glut depth buffer, definitely you have to enable your depth buffer algorithm. You have a algorithm known as depth buffer algorithm. You have to enable it, right? So GL enable, you are enabling your depth buffer algorithm. And now we can discuss about these callback functions. And this program is an example for event driven program, right? Events. What is events? When your input devices interact with the application program, it is known as event driven programs or event driven interactions. Right. So when your input devices, what are the input devices? You have your mouse, you have your keyboard. So through this input devices, if I am able to interact with your application program, I can say this is event driven interactions. Right. So here in our program, we are having few events. That is, while spinning the cube, right, you can use any of the mouse button to specify the direction of the spin, whether it should spin in clockwise direction or anti-clockwise direction, right? You can specify the direction of your spin using your input device, right? So you are having your mouse event, right? You are having your mouse event. You are having one more event, idle function, right? So this idle function, even if there is no event, right, if you want to perform some operation in your object rendered. So what object we have rendered now? We have rendered a color cube. So if I want to specify any action on that color cube, you can specify using idle function. So what is the role of this idle function? Even when there is no event happening, if you want some actions to be performed in your object, you can use this idle function. And reshape function. So when you resize your output window, when you maximize it or minimize it, this reshape function will be called. Reshape callback function is called, right? So when these events are happening, there are some values which are automatically given to that corresponding function. So you can see here, glut reshape function, it is a callback function. Inside this callback function, I am specifying the corresponding function name. My reshape is the function name. So when this event occurs, right, what is this event? Window event. What is window event? Maximizing your window or minimizing your window is your window event. So when this window event is happening, some values are given to your program. We can see what are those values. those values are named as measures, right? So when I maximize or minimize your window, there will be either a change in the width of your window or height of your window. So when that window even occurs, when you maximize it, what is the current width and current height of your window, that will be given automatically to your function my reshape. We can check, go to my reshape function. Yeah, here it is. So these are the values. See here, width and height. What are these width and height? What are these values? These values are known as measures. So how do this function receive this measure? When the event occurs, automatically this value will be given to this function. Right, you can check your main. I am not passing it where I have this function. I am not passing, but when that event occurs, automatically these values will be given to that function my reshape. So such values are known as measures. Similarly, when here you have one more callback function, mouse function. So when this callback function is called when there is a mouse event. What is mouse event? Right, clicking any one of the mouse button or moving the mouse or dragging the mouse. Right, these are mouse events. So when this mouse event occurs, some measures will be given automatically to your function mouse. Right, now let's see what are the measures given when there is a mouse function. So when there is a mouse function, right, now the measures given to the function mouse is which button I have pressed. So your mouse has left mouse button, right and middle mouse button. So which button I have clicked, and what is the status of your mouse button, whether it is up or down, whether I am holding your mouse button or I am releasing it, right? And the location of your mouse cursor. Location of your cursor. These are the values given to your function definition automatically when that event, which event, mouse event occurs. Right. Now we can see one by one. First callback function is reshape function. Reshape function occurs when there is a window event, when there is a change in the window width and height. So the measure is width and height. You have this width and height, and inside this I'll be specifying my projection matrix load identity, and GL ortho is the viewing function of my 3D object. Viewing function of my 3D object. So it will have 6 parameters. 2D will have 4 parameters: x min, x max, y min, y max. Along with that 4, you have 2 more, near and far. Along the x-axis, you will have this near and far. So totally 6 parameters for 3D viewing function, that is GL ortho. GL ortho. And you have to specify this model view matrix also. And you have your viewport. Viewport is the rectangular area of display. You can specify in your output window, you can specify a rectangular size, and if you use that viewport, your output will be displayed only in that specified rectangular area. Right. So to specify the rectangular area, I have this width and height. Width and height. This 0, 0 is the x and y location of your origin of your rectangle. Right. That is your viewport. Rectangular area of display. Next is next function is display function. So in display function, so how many buffers you are having, all those buffers should be cleared. Use GL clear and clear all the buffers. Here I am using double buffer, and one double buffer means color buffer and your depth buffer. Clear both the buffers, and you have to specify. So here, while spinning my cube, I will spin my cube along x-axis, along y-axis and along z-axis. Right. So here, the angle of rotation, and this is along x-axis, this is along y-axis, this is along z-axis. and you call your color cube. Where is your color cube function? Here is your color cube function, and here your, as I said, your cube has 6 faces. So now you have to render all the 6 faces, right? So here, this is my cube. You can see here we are having this front and back side, left side, opposite is right, top, bottom. Totally 6 faces we are having. This 6 faces I have to render now, right? So while rendering your color cube, if you take the front side as visible one, back side it will be invisible. If I am taking left as visible, right will be invisible. If I am taking top as visible, bottom will be invisible. That is, see, assume this is a cuboid. This is a cuboid, and hope you can see. Assume this is my front view. Front. So if I am looking the front side, the back side is exactly behind this front face. So if front is visible, back is invisible. Take this side. This is my left side. If I am viewing this left side, exactly behind the left side is my right side. So right will become invisible. Suppose if I am viewing this right side, exactly behind the back is right side, it will become invisible. Similarly, if I am viewing this top, right, exactly below this top is bottom. If this is visible, bottom will be invisible, right? So out of the 6 faces of your cube, 3 will be visible and 3 will be invisible. The visible faces I have to mark in anti-clockwise direction, and invisible faces or hidden faces I should mark in clockwise direction, right? So you can see here I am taking this front as visible. So visible I have to take in anti-clockwise direction. So this face, you check the vertex. This face has which vertex? 0, 1, 2 and 3. Out of this 4, find out the minimum one. Minimum is 0. So start from 0 in anti-clockwise direction. So it is 0, 3, 2, 1. Go to your polygon. 0, 3, 2, 1. This is how you got this number. You can't memorize these numbers. You have to understand, you have to draw, and you have to mark it. So this is front. So exactly behind this, you have this back face, which is a invisible one. Invisible one, how to mark? In clockwise. So clockwise, this will be in clockwise direction. Find the minimum vertex. 4 is the minimum vertex. Start from 4 in clockwise direction. So 4, 5, 6, 7. 4, 5, 6, 7. 4, 5, 6, 7. Similarly, if left is okay, so here if right is visible, left is hidden or invisible. So right is visible, which is the minimum vertex 2. Start from 2 in which direction? Anti-clockwise direction. Right, so it will be 2, 3, 7, 6. 2, 3, 7, 6. 2, 3, 7, 6. And left side is hidden. Start from the minimum vertex 0 and in clockwise direction. So it will be 0, 1, 5, 4. 0, 1, 5, 4. Check your program. 0, 1, 5, 4. Similarly, for top and bottom, you have to mark it. So where are we? Yeah, we are in color cube. And as I said, once the cube is rendered, you have to use this GL flush function to flush it. Then only you can see your output in your output window. And this glut swap buffers, I have told it already. Since we are spinning, this spinning, I have to specify the degree. Whether I have to spin 1 degree or 2 degree, you can specify the degree. And every time, if I have specified as 2 degrees, for 2 degree, the cube will be tilted. It will be rendered in that direction. And you have to, it will be rendered in that direction. And move the rendered cube from back buffer to front buffer for displaying. When this is displayed, cube will be tilted for another 2 degree, and cube in that slanting position, it will be rendered in the back buffer. Right? So once this rendering is over, it should be swapped to the front buffer for display. So when this cube is displayed, the same cube, it will be tilted for another 2 degrees. It will be rendered. So two buffers, I have to swap between buffers. So I have this black swap buffers. And here, front buffer is used for displaying and back buffer is for rendering. So that is the use of this glut swap buffers. And then this idle function. So as I said, even if there is no event, to specify some action, I will be using this idle function. So I have this spin cube. So where is that spin cube? So spin cube function should be there. Right. Next is your mouse function. Just a minute, students. Yeah, you have this mouse callback function. So which button you have clicked, the state of your mouse button and the location of your cursor will be the measure for these mouse event. So whether you are pressing your left mouse button or right or middle, right? So according to that, if you are pressing left mouse button, it will be spinning around x-axis, 1 for y-axis and 2 for z-axis. So you will be calling your spin cube. As I said, it will be tilted for 2 degree and your cube will be rotated. So when your rotation, so every time tilt by 2 degree and keep rotating. So when it exceeds 360 degree, you know one complete rotation is over. So next, when you get 362, you have to minus 362 minus 360. So it should start from the first step, 2 degree, 4 degree, 6 degree, and it should go on. So this is your spin cube function. And at last, you have to enable your GL depth algorithm. As I said, since we are using your depth buffer, you have to enable your depth algorithm, and it is mandatory. Hope I have completed all the functions. Yeah. So this is how we are going to create a color cube, and we are spinning it along the axis, along x-axis, along y-axis, and along z-axis. So if it is left mouse button, you are specifying the axis as 0. 0 means rotate along x-axis. Axis 1 means rotate along y-axis. Axis 2 means rotate along z-axis. Thank you.